Here we have one Flatlander, and he says the following, okay? Says, well, he said this before, okay? This was a comment he put a couple weeks ago. Said, quoting Professor Muller from Berkeley University, that gravity goes right through things. And this fellow says, what? Like it goes through a wall? And so I had to clarify that what Professor Muller was referring to was Newton's equation. Force equals gravitational constant g, mass 1 times mass 2 divided by distance squared. Okay, that's the universal gravitational formula. Okay, and so when I explained that in the last lecture, then he put a different comment. He said, oh, okay, gravity goes through things like you, me, and the earth. Yeah, that's better. Okay, so now he acknowledged that gravity goes through things. That's what Newton's equation depicts. That's what it is describing. Okay, but then he says, but gravity pulls on things like you, me, and the earth. Total contradiction. No rationale, misspelled, right? Or reason given. Okay, let's find out. Let's continue here with this fellow. And he says, Newton's equation, a description, not an explanation of gravity. Absolutely correct. Yeah, he figured one out. Yeah, it's a description. Mathematics, any equation is only a description. Mathematics has no power to explain anything. That's why so-called mathematical physicists never explained anything. Okay, they never explain. They have no right to explain. They have no special insight to explain. They can describe mathematically, but they cannot explain the causes, the mechanisms. That's why we have all mechanisms today, all theories today coming from mathematical physics are irrational for invisible, intangible mediators, right, or events. Okay, he says, you have said nothing new to me. Well, I guess he wasn't paying attention because there he says, he continues, says, you provide no explanation for acceleration of objects in your rope model. Changing only the angles of the ropes from a coaxial to fanning out, as demonstrated by your simulation, does not explain change in momentum. Well, I wasn't trying to explain change in momentum. I was trying to explain gravity, okay? He called it change in momentum. Maybe he was thinking about something else, okay? I was trying to explain the acceleration of gravity, okay? From a physical point of view, I was trying to explain a mechanism. I illustrated it. He didn't understand it. He says that the fact that I went from angles to fanning out, a single angle to, or a single coaxial to fanning out did not explain gravity as far as he was concerned. You state weight is static. Correct. Weight is a static concept. Then he says changeless. I don't know what he means by changeless. I didn't say changeless. This is his irrational interpretation of what weight is static means. Weight is static means that weight is a static concept, means that you have weight for a single location anywhere in the universe. Anywhere in the universe, you have a given weight with respect to something else. Okay? And we'll get into that in a second in more detail. Yet, when the location of an object changes, weight changes. Yeah, see, again, he's talking about the word change. That's not what we're talking about. We're saying weight is static, and if you move to another location, static location, you have a different weight. Okay, so you do change weight. Okay, you do change weight. That's why this changeless is something he misunderstood. That is a description, not an explanation. Again, he missed the whole boat. Okay, an explanation that a child can understand like a rope pulling a donkey. Well, I guess he's got to go back to kindergarten because he did not understand the explanation, which was exactly like a rope pulling a donkey. Okay, and where does his ignorance and arrogance, right, originate? Well, it originates here. Okay, and this is important to see in his case. Explanation is the domain of religion. Okay, so he thinks an explanation, a mechanism, right, of how something happened. For example, a kid threw a stone through the window, and we see the window on the floor, and we say, how did this happen? And a fellow says, well, a stone went through the window, or a brick went through a window. And that's an explanation. That's a mechanism of how the glass ended up on the floor. He says that's religion. Okay? Now he continues, says, neither Galileo or Darwin could explain their observations. And I'll include Newton there. Yeah, they freely admitted they only described what they observed. And yeah, all these people, mathematicians, they never could explain anything. So they only described. Right? In the case of Darwin, I would make an exception. I would say that he did explain, okay? But I'm not going to get into that. My point is that in mathematics, okay, people like Galileo, Newton, they only described because all they did was equations. And in the case of Galileo, he did a lot of description, verbal descriptions without having to go into equations. But they were, again, descriptions. Okay? He never explained why, the causes of gravity. He just explained, this is what it does. And then he continues, says, religion, a topic of today, right, has a long recorded history of wrong predictions. Okay? I guess he's referring to general relativity and quantum mechanics because general relativity predicted that matter arose out of nothing, Big Bang Theory. So I don't know how that prediction, in retrospect, right? Retrospect prediction happened. I don't know how they can predict that a black hole, which is a zero-dimensional nothing, attracts, a star or swallows a star or swallows matter. So all the predictions of these people are wrong. How can a particle be at two places at once? So all these predictions from so-called science, mathematical physics, they're all irrational, let alone wrong. Many lives were, are, and will be improved because of better ways to predict events in the future. Well, I don't know what prediction has to do with anything at all, why he even mentioned this. What's it got to do with improvement? He's talking about, I guess, technology, and he thinks technology has something to do with science, okay? Without any explanation required. Explanations only satisfy those who demand answers that can't be questioned. Okay, again, none of that has anything to do with science. Science is exclusively explaining. That's what science is. You have to break your brain to explain, especially the invisible, intangible world of Mother Nature. And you don't have to believe it, but you do have to explain it. You have to explain the mechanism so that someone understands what you're proposing for how the universe works. So if someone says, how does gravity work, for example, why doesn't the Earth fly out of the solar system? You got to give an explanation to that question. And for that, you have to have a mechanism. It doesn't mean that the listener is going to believe in your mechanism. It means you provide one so that he understands what you're proposing. Now you can say, look, angels are pushing the earth around the sun. Okay, that's your version. We understand it. You draw the angel, you show him pushing the earth around the sun. We understood it. Okay, we have your explanation for how you think the earth goes around the sun. No problem. But it doesn't mean that the listener is going to believe that explanation, but you do have an explanation. And for this fellow to say that all explanations are religion, obviously he's not going to understand anything that I teach here. I don't even know what he's doing here. He's got the brain to clean latrines at the bus stop. I don't know what he's doing in a science channel. Okay? What answers is he looking for if he's not looking for explanations? Okay, so let's explain to him what he missed. Okay, let's explain. Maybe the second time he gets it. You never know. Okay, or third time, because I think this is the third time. He says, my stupid inquiries and arrogant assumptions make me laugh. Yeah, not only you, we're all laughing. So keep going. You're a great stand-up comedian. Okay, I don't mean to come off arrogant. Have some compassion, Bill. We all can't be geniuses like you. Yeah, these people are ultra arrogant and ignorant. And they say, oh, I'm not arrogant, I'm not but see, it shows in every word that they pronounce. They don't fool anyone. Okay, so yeah, I don't have any problem with dealing with all these people. That's why when some people come here and say, oh, you said poo-poo, Bill, you called me a poo-poo, my God, grow up. That's all I can tell you. Okay, here's where we start. We have Muller again, Mr. Richard Muller from Berkeley University, and this is what he said. Okay, and I think I've got the link there. You can look it up. It says the following. He says, every atom on the earth is pulling on every atom of you. You're also pulling on it. The amazing thing about gravity is that it goes right through things. Okay, so what problem does this fellow have? He says, how can you be pulling at the same thing as going right through things? That's where he's got his what he thinks is a contradiction or irrationality in his mind. Okay, because again, he's thinking of particles probably, and he says, okay, the particle goes through you, that he can understand. Maybe they're invisible particles, whatever, and intangible particles, okay, no problem. But then how do they pull? So this is what he can't understand, okay? So how do we answer? Okay, well, first, let's show an example here, okay? Here we see that the gravity, which is that yellow line, okay, we're just representing it with a yellow line. And what we're saying is that gravity somehow goes through everything, goes through the wall, goes through you, goes through the ball behind you, and keeps going. Whatever gravity is, it traverses everything. You can't put a shield in front of you, an anti-gravity shield, because it'll pull you right through the shield and the shield with you. Okay, so you can't shield yourself from gravity anywhere in the universe. There is no such thing as a gravity shield. Okay, anti-gravity, that's something else. That's called life. Okay, life is anti-gravity. But gravity shield, there's nothing in the universe. God has not invented it yet. Okay, and so here's the situation. Okay, here we have the Earth. Okay, this is what we're going to explain to this gentleman. Okay, here we have the Earth, and we have it at two locations. We will assume, right, that the Earth could be closer to the sun or much farther away. Case number one, you're far away. Case number two, you're closer to the earth, to the sun. If the earth is closer to the sun, assuming we could do that, if we could move the earth somehow closer to the sun, it would weigh more with respect to the sun than where it's at right now. Okay, that's what Newton's equation tells us. That's that distance squared in the denominator. Okay, do we have that? Do we understand that equation? The equation says that the farther away you are, the less you weigh. Okay? Okay, now, we need to clarify that it's a question of location. And again, we have to clarify that location is a static concept. Location occupies a single frame in the universal movie. Location is just a bunch of distances, another static concept, right, between atoms. We're not talking about distance traveled. We're talking about, which is the mathematical distance. We're talking about distance of physics, separation. There's separation between any two objects in the universe. Okay, so we're saying if we look at a single frame, not even an electron is moving in that frame. Nothing is moving. It's a snapshot. It's a picture. It's a photograph. Whatever other word you want to, painting, whatever word you want to use there. Okay, so we're saying that in one case, we're saying that weight is a static concept. There is no motion whatsoever. If you're just far away from the sun, you have a certain weight. And if you are closer to the sun in just a single frame of that movie, you weigh more. Weight is a static concept. There is no motion required for weight. Okay, I hope that, I don't know how else to clarify that for, at least for intelligent people. People who have mental problems, well, they might have a little bit of problem. They don't understand what I'm talking about. How do we explain this? How is it possible, okay, that if you're farther away from the sun, you weigh less at one location, snapshot? Not even an electron moves. Nothing moves. It's a cross-section of time in the universe. It's the now, the cutting edge of events. Any way you want to visualize that. How come you weigh less there and you weigh more if you were closer to the sun, static location, a certain separation from you and the sun, no motion, no electrons moves, picture, snapshot, same thing, same issue. How is it that you weigh less over here? How is it that you weigh more over here? We're not talking about motion. It's not that you moved, okay? We're saying if we take a snapshot, you weigh more here, weigh less here, and you weigh more here. That's what we're saying. Closer to the sun, you weigh more at a location. Static concept. Farther away, you weigh less. That's what Newton's equation tells you. The distance in the denominator is not distance traveled. There's no motion in that distance. It's separation between two masses which are in the numerator. Okay? Someone following me out there? Okay, how do we explain it? Here we have it. We explain it with ropes. Okay? It's not only the angle as this individual insinuated there. It's more than that. We have more effective ropes. Okay. Now, the way I did it here is just for illustration. I showed fewer ropes on the weigh less on the scenario number one, and I put more ropes, okay, on number two. What did Mr. Richard Muller say? He says that every atom of the sun is pulling on every atom of the earth. Every atom on earth is pulling on every atom of the sun. That means every atom in the earth is connected to every atom of the sun and vice versa. What happens with these ropes, which are the ones that are connecting every single atom of these two objects? What happens when the earth comes closer to the sun? Well, the ropes fan out. You have more effective ropes. You have more effective ropes. The number of ropes has not changed in the universe. What changes effective ropes for this specific event? What do we mean by effective ropes? Let's go through that. Okay, here's the definition of effective rope. We have a cube and we have a cylinder. The cube has 5 atoms. We don't care about all the others. And the cylinder has 1 atom, number 6 there. Okay. All the atoms in a cube are aligned on the same axis, exactly on the same axis. Okay, they're all connected to atom number 6 along the same axis. That means all the ropes are superimposed one on top of the other, one inside the other. Ropes have no ability to touch ropes. Touch is forbidden in Mother Nature's universe. That is the assumption. Okay, so no ropes can touch another rope. They can superimpose. Just like in quantum, 2 particles can be at the same location, right? Here, the same thing. 2 ropes can be exactly at the same location at the same time. Okay, do we have that? So we have 1 effective rope. As far as the cylinder is concerned, it just sees 1 rope because all these 5 atoms are on the same axis. what happens when the distance changes? It's not motion we're talking about separation. The separation changes. Suddenly the cylinder is closer to the cube. You see what happened to the 5 ropes. Somehow they fanned out. Now each one is pulling, you could say pulling, right? Individually, separate from the axis, okay, where they were before. So now you have what we call 5 effective ropes, and that's why the attraction of gravity is stronger, okay? So with those 5 different ropes, effective ropes, you pull more, or you have more stronger gravity than you had with 1 rope, okay? On the right-hand side, upper right there, you can see a general picture. 2 objects very far apart from each other. All the ropes superimpose and form a single coaxial, you could say. So if you can look at maybe the nearest star, it's so far away that all the ropes superimpose, and that's why gravity is weak, because they all act like one single rope almost. Okay? What happens when the objects approach each other? Well, you can see what's happening to the ropes. They are no longer on the same axis. So it's not only the angle, it's that you have more effective ropes. Okay, so that's the theory. The reason for gravitational acceleration has to do with the ropes fanning out, and meaning that we have more effective ropes. You want to use another word, use another word. I use the word effective ropes. Okay. Anyways, all I can say to this fellow is, please try to understand before one of us dies, as Mr. Faulty Towers, Basil Faulty said in Faulty Towers, okay? So please try to understand before one of us dies, okay? And we do have our way of educating, of learning them, okay? We're going to learn you, okay? Yes, anyways, that's the acceleration of gravity. Now, one person asked a decent question, okay, so we're going to address that one, okay, which is an important question. A lot of people have this in the back of their minds if they haven't asked so far. Okay, said, you said your ropes are non-tangible. So why would you say atoms are made your ropes when we know that atoms are tangible? Good question. The rope is pushed by the atom. Okay, well, not really pushed by the atom. Remember, the atom slides along the rope. But this, let's continue here. This means the atoms are tangible to the rope. It's not tangible. It's that the rope becomes the atom. Okay, so let's just clarify that. But that's not the question I want to answer. I want to answer the first part there. How can the rope be intangible and it creates something like an atom which is tangible? That's a valid question, okay, under the rope model. It seems that sometimes ropes are tangible, but sometimes they are not. For example, in the case of magnetism, ropes are tangible with each other. Not ropes. Again, people are not paying attention. It's threads. Okay? The rope is not a thread. The thread is not a rope. 2 threads are necessary to make a rope. You twine 2 threads, one around the other, you make a rope. You untwine a rope, you have a thread. People keep talking about rope theory and thread, bringing rope into magnetism. Ropes are not the ones that are swinging in magnetism. It's the threads. Please get that right. It means you're not even paying attention. Okay? Okay, but let's answer the first part of this question here, or concern, okay? First, we're going to consult Mother Nature. Let's ask her. Let's see how she does tangibility, okay? Because if ropes and threads are intangible, and they construct atoms, and they also, in the case of threads, they make up the walls that comprise magnetism, and you have some interaction there, then the question is, how does Mother Nature do this? How does she take intangibility and turn it into tangibility? That's what people want to understand. That's what they want to know. Okay, so let's ask Mother Nature, and she says, I produce tangibility through aggregation. Okay, we're going to produce tangibility through aggregation. Okay, that's how she does tangible. Okay, touchable. Tangibility. Okay, what do we mean by that? Okay, here we go. Okay, here's the rope, the construction of an atom. Okay, look at it carefully. Try to understand. We don't care if you believe or not. We want you to understand. That's very hard to get people to understand. Okay, here's the atom. How is it constructed? Okay, we have the electric thread that goes through the atom, forms the proton dandelion, a little star that's in the center of the atom. The center of the atom is not a little ball, or you could say it is, but it's made up of all these rays that are actually threads coming from every atom in the universe. Every atom in the universe. Okay, some people say, well, how can that possibly be? You got all these atoms in the universe. You got, gazillions of them, and they converge upon our atom and build this tiny little thing with all these threads and ropes from every atom in the universe. Yeah, ropes do not have the ability to touch. Threads do not have the ability to touch. Until you understand that, you will not make any progress. Okay, so yes, they do not have the. You have to forget about touch. Okay, touch is our macro world, meaning atom and above. Okay, below atom, there is no such thing as touch. Mother Nature never invented touch for her mediators, which are the ropes which construct the atom. There you see the ropes impinging on the electron shell, the red line there. Okay, here you see it one more time. Okay, magnetic thread goes around, encapsulates the proton star, and comes out the other end as another rope. And you have all these ropes from every atom in the universe converging upon our atom. And one thread goes through the center, fills the proton star. Okay, and this is more or less what it looks like in big picture. Okay, so we got the construction. We don't want you to believe it. We want you to accept it as an assumption. Okay, this is what we're going to start with. We're going to put this assumption. Okay, so here we go. This is what our atom looks like. 2D on the left side, 3D on the right-hand side. Okay, all the ropes from every atom in the universe converge upon our atom. One thread, we'll call it the blue thread, the electric thread. This is just arbitrary. Okay, goes through the center of the atom and builds this star-like entity. Looks like a rolled up urchin, pointing its quills to every atom in the universe, right? And the other, the red one in this case, what we call the magnetic thread, goes around and encapsulates, the proton star. So you have a 2D version, you have the 3D version to get an idea of what we are proposing. Okay? Do you believe it? We don't care. This is what we're proposing so that you understand the theory founded upon it. Okay, here we have our atom, okay? And again, you can see that the atom is, especially the electron shell, which is the encapsulating medium, right? The membrane. It's built by countless threads. Okay, do we have that? Thread from every atom in the universe, from every rope in the universe converging upon our atom. One thread, in this case, the blue or light blue thread, goes around, builds our electron shell, electron membrane. That membrane is going to encapsulate inside there the proton star. Do we have that? Okay, that's what we're proposing. Do you believe it? We don't care. We're not talking about belief here. We're talking about assumptions. We want you to recognize or understand the assumption so that you can follow the presentation and understand the theories founded upon it. Okay, here we move forward, and what you have to understand that those threads are not standing still. It's not a ball of yarn in a sense, okay? They're moving around, okay? So when we talk about, all these threads that converge upon our electron shell, the electron shell is a dynamic entity. It's constantly moving around because the threads are scanning, they're sweeping around the entire shell. So they're constantly in motion. That's why people think that the electron is moving. Okay, the electron in quantum mechanics is just one little dot, one location there, and they say, well, we don't know where it's at. Of course you don't know where it's at because it's kind of like everywhere, because the electron is not a tiny ball. It's a bunch of threads that are weaving around the atom, forming the electron shell, and the threads are in motion. They're sweeping around, they're swinging around the surface of the atom. Okay, so this is more or less what we're proposing. Do you believe it? We don't care if you do or not. The electron is not like that, and it's standing still. Okay, the electron has these threads sweeping constantly around. Okay, and I think at least we're proposing that the electron shell is pretty much as close as you get to a perfect circular or spherical object. Okay, now, I mean, it's rough surface. It looks more or less like that. Okay, so it's like a ball of yarn in that sense, but the yarns are dynamic. They're moving around. This thing is in constant motion. In fact, great speeds. Okay, so how about magnetism? Here we have magnetism. Okay, and again, how does she produce Mother Nature? She produces magnetism, or what is called a magnetic field, with aggregation. Is it with ropes? No, it's done with threads. Now we're talking about threads, okay? Do not confuse the thread with a rope. Two threads make a rope. Half a rope is a thread. Okay, more or less. You got that? Okay, so here it is. We have the threads swinging around. I didn't draw all the threads. We're talking about gazillions of threads here, okay, from a magnet. But they're sweeping around like walls, okay, walls of threads. And yeah, when you have that aggregation, many threads forming walls and all these walls sweeping around at great speeds, well, then threads go through threads, but at the same time, they create this friction because of the aggregation. Here it is. Again, I haven't drawn every thread, so please do not criticize me for that, okay? Here it is. You have two magnets, okay? And you can see what the threads are doing. They're sweeping around. There's countless of these. And even though you see thread, we're talking about really walls of threads, okay? And they're sweeping around. When you turn the magnet around, okay, so that clockwise, well, first, we still have attraction when you just roll it sideways, but when you turn it 180 degrees, we can see what happens. They push each other away. Why? Because the threads are banging against each other now. Okay, so we have attraction, okay, both clockwise at the top, both counterclockwise at the bottom. Okay, you can see what's happening. If you turn it sideways, nothing changes. But when you turn it 180 degrees, we should have repulsion, and we do. Because why? Because now the threads are going in the opposite direction. Okay, so that's the mechanism. Okay, think of it as a flip book. Okay, here's a flip book. Okay, and you can see what's happening. We're saying that the threads form these pages. Okay, so that's your magnetic fields or walls that form the magnetic field, the whole thing. The whole book is the magnetic field. And it's something that goes on continuously. Okay, it doesn't stop. Okay, unless it loses strength. Yeah, that's a long story. But think of it as a flip book. And what happens when you put two flip books side by side? Well, you get something like this. Okay, the one on the left is going counterclockwise, all the pages. Okay, and the one on the right is also going counterclockwise. What happens when the pages on the right hand side of the first one, or the one on the left, pages on the right hand side go up, the pages on the left hand side of the second one go down, and that's when they interact. Because what are we talking about? We're talking about countless threads forming walls which form the so-called magnetic field. Magnetic field is a dynamic entity. Okay? As Mr. Maxwell said, you know, in that region, magnetic field, there is matter in motion. Matter in motion. An exotic type of matter for sure, but matter in motion. Okay? And so, yeah, that's when you produce tangibility. You produce tangibility first when you have aggregation. In the case of the electron shell, okay, you have all these threads that are moving around. Okay, now you have a surface, so you can put one atom against another and it will touch. And likewise for magnets, you know, you have two magnets. Here we have these two little magnets, okay? And what's in there are countless threads that you cannot see or touch, right, with your hand. Okay, you can touch them with iron filings, but you can't touch them with your hand. Okay, because your hand is not subject to that type of magnetic field there. That's a long story. But the point is, there you have a magnetic field. What did Maxwell say about a magnetic field? Well, there is matter in motion. That's what a magnetic field is. Don't talk to me about a static magnetic field, because even a static magnetic field has matter in motion. Okay, static magnetic field has matter in motion in there. And so what's happened? Why do they attract? Because one is going this way and the other one's going this. So they're both going in the same direction. Let's do it this way here. They're both going like that, right? So as this one comes down, this one's coming up. Okay? Remember, this one comes down, this one comes up. That's what's happening. And that friction is what's countless friction, because you have one wall right after another. That's what pulls the magnets together. And the closer they are together, more threads, more walls of threads intervene, because now they're closer to each other. Now the atoms that are farther away are closer together also. Those are also engaging in the action. And now the strength of the attraction is greater. And the closer they are, more, you have a stronger attraction. So, it explains quite well. The rope model with the threads, swinging threads, explains quite well attraction between two magnets and repulsion. You have a mechanism now. But by saying, giving you an equation, we have described, but we have not explained how Mother Nature does that magic trick.